Callis, president of the Hot Springs Village Camera Club, and we have a really good presentation here for you today. I'm going to introduce to you a guy that's just amazing at night photography, Peter Trabant. He's led some wonderful field trips and taught me how fun it is to photograph the night sky. But we're going to be talking about the Total Eclipse, which is coming to Hot Springs Village on April 8th. And I'm going to let Peter start with his presentation because you're not here to hear me ramble. He's got a lot of initials after his name, and I can't even begin to tell you what they all are. But Peter, if you would come up and, where did he go? Ah, there you are. Thank you, Peter.
Thank you, Jennifer. And I'd like to thank both the Camera Club and the Village Stargazers for putting this together. And I worked with them because I'm a member of both clubs. We put a series of articles together that were published in both The Voice. Can you hear me all right?
Yes.
Okay. I put a series of articles together over the last 6, 8 months that have been in both The Voice and the Gazette, explaining what to expect on April 8th in terms of everything you need to know about an eclipse. So, a round of applause for both clubs for doing all this. I guess to introduce myself, all I can say is I've been involved in photography since I was a child. My father was a photo editor of Life magazine, and we moved to Germany. We lived in Germany, and I grew up in France, mostly, and then a service for 5 years, and then finally University of Miami, and then worked for an oil company for a year, and ended up going to Texas A&M and working there for 10 years doing research on oceanography. So I've got degrees in oceanography and civil engineering, and with that, upon retirement here, I got into photography in a deeper way, and now I've gotten into what we call astrophotography, or AP. And this is a result of that, is getting interested in taking pictures of the sun. So I'm going to start this all over again. Russellville, but are coming down to the village one night. I think it's the 7th or 6th, I'm not sure. Friday night. Friday night before the eclipse, they'll be talking at the Woodlands. So you're all welcome to attend that. So, looks good. Can't see, but that's all right. Oh, I was going to wear my glasses. I got my glasses on my hat here, and I can't see if I wear them. And that causes problems sometimes. So here we go. Are you ready? Total Solar Eclipse is Monday, April 8th, coming 25 days from today. My talk has a list of pictures and things that I did in 2017 when I went up to Cape Girardeau and took pictures of the last eclipse to come through. Our coming eclipse, April 8th. Where to watch it, Monday at noon. How to watch it with solar glasses, and how to capture it, either your cell phone, camera, or even just a memory. So what's the big deal? Only 7 total solar eclipses pass over North America this century. So we're lucky to have had 2 that come through here within a few years period. I've got stars here that show you where they occurred. One is just north of the village. The lower star is for the village. Okay, there's Cape Girardeau, Missouri. We drove up there and took pictures of the eclipse back in 2017, and it was awesome. It was my first eclipse where I really concentrated on taking pictures of it, although I'd seen one other. And then there we are in the village. Here's the one that's coming through this year, right here. It will be coming through Mexico, Texas. It will be hitting Dallas, and even Austin and San Antonio. And then it goes through here and up to the northeast and out through Maine. The previous one just went through this area here. The intersection of two eclipses is a very important place if you're taking pictures. For some reason, people like to be at that same spot. So it's something that's done once in a while. We have the luck of the draw here in Hot Springs Village to have the eclipse come through and be centered right over us. We are directly on the path of totality, and we should appreciate that. Meanwhile, the exact center of the 80-mile wide track will be on the western side of Lake Ouachita. So, let's look at the sizes of things. The sun is 400 times wider than the sun, but it's 400 times further away. The net result is that the moon can move in front of the sun and block it out in totality, so that all you see is the periphery of light that's emanating from the sun, and that's the corona, or atmosphere, otherwise known as the heliosphere. The scientific importance of this is that it's the only time we get to really see the corona of the sun, is during an eclipse. And for that reason, astronomers in principle that study the sun have always looked for eclipses and gone and taken pictures and observed all these phenomena. This was the eclipse of 2017, a picture I took up in Cape Girardeau. This is a sketch of what it looks like. We have the sun on your left, the moon in the center, and then that narrow band that goes down on towards the earth is the umbra, or the shadow. And then if you only see a partial eclipse and you'd be further away from the village than say 30, 40 miles, you'll just see a portion of the sun covered by the moon. That's the penumbra, and it's a large area. Meanwhile, all these orbits are going around, and we calculate these for thousands of years ahead of time if we want, and we know exactly when eclipses are going to occur. This is a picture, and these are all real pictures except for the one of Earth, of course, because we can't get away from it and take the picture. But a guy named Andy McCarthy lives in Arizona and takes pictures from his backyard. And this is a picture, and they're all scaled to size, of the sun, of course, in the middle. And then those four little round things above the blue arrow are the inner planets: Mercury, Venus, Earth, and Mars. We're right in there, the third rock from the sun. And then the outer ones, the outer planets, include Jupiter, Saturn, Uranus, and Neptune, and they're much bigger than we are. They also have many more moons than we do. For instance, Jupiter and Saturn both have over 100 moons. We only have one. And another event to look at is the temperature of the sun at its surface is 10,000 degrees Fahrenheit. Pretty hot. Mercury is very hot too because it's pretty close to the sun. Venus has a temperature of 867 degrees. That's pretty warm too, and that's mainly because of the greenhouse effect. It's locked up in vapors and it's keeping the heat towards the planet. Earth is at the idyllic 59 degrees, which mankind evolved with, and all the species on Earth have, at least for the last 3 million years. And it's at 59 degrees. And Mars is a minus 85 degrees, it's as cold as the Antarctic. This is a site in Cape Girardeau that we drove up to. My wife and I spent the night and then set up the camera where I've got the little yellow circle. I put my camera there, and the camera's sitting right here that I took the pictures I have of the eclipse. And I've added one thing, but it's a pretty simple rig. And took a lot of time in reading, mostly online on the internet, to find out what kind of settings you needed and how to take pictures of it. So I learned a lot that time. I also learned how not to make mistakes, because we all do. And I'll go show you what they were. These are the events. I'm taking the pictures that I took in 2017, and I'm using those as an illustration for you to show you what the events are as the eclipse takes place. And the first thing you see is first contact. This is when the moon first starts obscuring a piece of the sun. And that's called phase 1, first contact, and it will occur at 12:32 p.m. on April 8th, that's a Monday. Partial phase 1. That's followed by the complete obscuration of the sun. That takes place, that's when totality occurs, is second contact, and that will be at 1:49:38 p.m. 1:49. It'll last nearly 4 minutes, which is a long time. The one I saw in Cape Girardeau lasted less than 2 minutes. We're gonna have 4 full minutes of the eclipse. Wonderful, it should be an experience to really appreciate. Finally, as this, during totality, so at totality when we were up in Cape Girardeau, the skies darkened, the horizon all lit up as if you were looking at sunrise or sunset. There's an orange glow, it's eerie, and it's all the way around, 360 degrees. It's like watching the sunset, but it's everywhere around you. And it gets dark and cool, the wind sort of stops, and then all of a sudden you realize everything's very, very quiet, simply because the animals, the birds, and the insects they think it's nighttime, literally. So this is one of the awesome things that we see during an eclipse. I think one of the important things to remember are the eeriness of it, the shadow bands. These are little dancing figures that come across the ground as the eclipse is in totality. And if you have a white sheet and you lay it out on your lawn or wherever you're going to be looking at the eclipse, you will see these little figures dance across the sheet. Just before and just after total eclipse, you have this figure that they call the diamond ring. And this is where you get a big blast of sunlight coming right over the edge of the moon, and they call it a diamond ring because it looks like a diamond ring. Pretty cool feature, and it's something that when you're taking pictures of an eclipse, you want to try and capture it. There's also, just before you get the big bright light of the diamond, you get Bailey's beads, they call them. And these are little round dots, I'll show you here, that occur just before you get total eclipse wipeout. And what they are light rays going down through the mountains and between the craters on the moon. And so you get these little bumps of light. And that's known as Bailey's beads. This is a picture of the totality of an eclipse with the diamond ring, Bailey's beads. It was taken by Frank Espinac, who used to be at NASA. He's known as Mr. Eclipse, and he was NASA's specialist in eclipses for decades. And finally, the sun becomes clear again, the moon moves off, and that's the end. That's fourth contact, when it loses contact, and the eclipse ends at 3:10 p.m. that afternoon. That'll be on Monday, the 8th of April. This is my best picture, at least in my opinion, of the event as I watched them take place in Cape Girardeau. Thank you. And the reason I say that is because you see these beautiful patterns of magnetic fields surrounding the sun and all the emanations that take place with this, because the sun is nothing but a great big ball of hydrogen that's being converted by squeezing the hydrogen atoms together into helium, and this is what we call nuclear fusion. A great big ball of nuclear fusion taking place, And this will go on until all the hydrogen is consumed, and then there's nothing but hydrogen left, or helium left, and when that happens, the whole system collapses, and then it becomes a white dwarf. These are the shadow bands I was talking about. This is a picture of shadow bands taken here in the village just recently when we had the October 14th partial eclipse. And Cheryl Downton's husband, for those who know Cheryl, took this picture with his cell phone. Well, what's gonna happen on that day? We do not know. Today we were hoping to have a sunny day where we could all go outside and look at the sun. And I think we will have some sun, but we'll see by the time I finish giving you the talk. But the arrow there at HSV shows that we have approximately a 50% chance of having a clear day, or a cloudy day, whichever way you want to look at it, for the event on April 8th. And let's hope and pray for a nice, beautiful, clear sky when it happens. Safety is paramount during an eclipse. Never look directly at the sun. And when it does occur and you want to watch it, wear glasses. I have a pair here that are on my head. Of course, you can't see me probably, but I can't see you either when I put them on. And you can either get film, you can mount film, or you can get paper glasses that have film on them. In the old days, we used to use a welder's hat or a welder's glass, but there are many ways to look at the sun and not damage your eyes or your camera lens. So it's important that, except during the total phase, which is when the sun is totally blocked out, you can take your glasses off and then look at it. You might see the stars. You should see the stars around it because it'll be like nighttime. But that's the only time you can take it off. The same thing applies to your camera. When you're taking pictures, and this is my camera rig, I have a filter on my camera. And in 2017 in Cape Girardeau, I was taking pictures of the eclipse, and all of a sudden the full eclipse occurred, and I couldn't see the sun anymore on my camera. I thought my battery had died, so I quickly grabbed a spare battery and put that in. It still didn't work. I checked everything, I couldn't figure it out, and then all of a sudden, uh-oh, I forgot to take the filter off. Such a simple little thing. But you get carried away during an eclipse because it's such an awesome experience that it's easy to forget things. And I think one of the best pieces of advice that I was given recently about taking pictures during an eclipse is do it all by yourself somewhere where no one's around to bother you. My wife was going to have a solar eclipse party, and I had to say, I want to be able, I've got 3 cameras running, taking pictures of this eclipse, so they're all set up. But I don't want to be distracted is the point. At any rate, this is my camera rig that I used, and starting at the bottom, on your right, there's a tripod. The tripod's right here. It's a heavy-duty tripod, and then on it I have a swiveling mount so that I can adjust the camera to follow the sun as it moves. I also have a sun spotting tube alongside it, which I built. It's just a PVC tube with one end patched up with just a pinhole in it, and then a piece of tape on the back. And what it does is when it's lined up straight with the sun comes in that pinhole, and then it shows up on the tape in the back, and I can tell exactly if I'm lined up with the sun or not. And it's a pretty convenient way to follow the sun, which you can't do by looking at it, because if you have these sunglasses on for looking at the sun, you can't see your camera. It's a complicated thing, and this is why it's highly recommended that you take pictures of the sun on a day like today before the eclipse, and you get used to taking pictures like that with and without your glasses on. Finally, my camera is a 6D DSLR last time. I'll be using an R5 this time, a Canon again. I've got a special lens now. It's a 800mm lens, one piece. But this time, 5 years ago, I used a doubler, an X2, and a 100 to 400 millimeter lens. So I had effectively 800 millimeter lens on the camera, and I topped that with a solar filter that you screw in. And that's another problem I had. It was a screw-in filter, and when I had to unscrew it, when I realized I had made the mistake of not removing it, it undid the focus of my camera. So I lost the good focus that I'd set up on the camera to start the event, and then all of a sudden, I didn't have very good pictures. That was a mistake. We learned. Meanwhile, I've learned you can also get these little filters that are magnetic. And so all I have to do is reach up and pop it off when it comes to the full eclipse. If you're using a cell phone, it must be covered too, or you'll burn up the sensor, the photographic sensor on the cell phone. And it's very simple, like this woman's doing, just putting a pair of sunglasses or solar glasses on top of the lens, or you can cut them out and put them on a piece of cardboard that you then apply and literally tape to your cell phone. Many ways of doing it, but it's important to cover your cell phones or your camera phones, the lenses, with some kind of solar filtering. Otherwise, you will burn the sensors up on them. Now the issue, I'm addressing the Camera Club members here and anyone who's going to be taking pictures of it. What settings should I use? It's a common question. I didn't know what to do at first, particularly last time when I did take a picture of the eclipse. But now I know a few tricks. And this is one, and it's very valuable because it simplifies the entire operation. I'm using a lens of 800 millimeter, but you could use anything between 300 and 1200 millimeters. They'll work fine. The smaller lenses, like 300, 500 millimeter, will give you a smaller picture of the sun, but you'll still get good pictures. And if it's anything over like 900 millimeters, you're going to be squeezing a lot of the sun into your pictures, and you might not catch all the aurora that goes out around the outside of the sun. So 800 millimeters is nearly ideal. So your settings should be quite simple. Use an ISO setting of about 100 or 200. You want real good quality in your picture. Above all, manual mode, no automatic focusing or anything like that. You're going to set everything up manually, so you don't have to worry about anything else on the camera except one thing. Using your aperture of f11, right in the middle setting normal, leave it at that. You don't have to touch it once you got those two settings in your camera. All you have to change is the speed of your shutter, and that's pretty simple. You start out before the eclipse, taking a picture of the sun and adjust the focus very clearly to the edges of the sun. And that you have the filter on, you're taking a picture of the sun, and most cameras now have a little magnifying function where you can magnify the sun and look at it very closely, right at the edge of the sun, and make it as sharp as you can. Once you've got that set, some people tape their camera so that it won't change the focus as they're working with it. Once you've got that set and these settings, you don't have to touch anything except the speed. And you start out at like 1/10 of a second, and then you keep going up to higher speeds until you get a nice pretty picture of the sun. Once you've got that, you just leave it and take pictures. Or in my case, I have an automatic function on my camera where I can say take a picture every minute, a timer, an interval timer. But focus, very important. You want a nice clear picture. And speed, I also do a bracketing, which is I take pictures one f-stop or two f-stops below and above the setting I have in the camera. So every time it takes a picture, it takes 3 pictures. One a little less speed, one a little more speed. And the net result is after the event, I can look at them and pick out the best pictures. But above all, you gotta remove that filter right at the moment of totality. And we'll have 4 minutes of it here, and that's when you get the beautiful pictures of the edge of the sun. So that was for the Camera Club. Now, a few things for, I think, more directed towards the village stargazers who look at things a little bit closer than photographers might. Here's some fun facts for you. Geomagnetic storms occur on the surface of the sun. There's sunspots that I'll be talking about in a minute. And these flares are enormous. I'll show you a picture at the end that has a 120,000 mile long solar flare. And there's CMEs, these are coronal mass ejections. This is when one of these flares occurs and it shoots out a bunch of ions and plasma out into space. And if Earth happened to be in its way, if it's weak, it'll make tremendous auroras, as you see on the right-hand side. That's an aurora from this past winter over Sweden. And it also has the ability to disable satellite communications and burn up transformers and electricity. This is something that we've been very concerned about with our infrastructure in case anything like this happens. And we monitor the sun permanently by NASA and NOAA in order to find out if there ever is a coronal mass ejection that's coming out towards the Earth. It takes 18 hours to get here, so they're ready and prepared to warn people that it's coming. And you wouldn't believe it, but when there are warnings, and they have occurred in the past quite often, they shut down satellites and they shut down the electricity in this country just for a fraction of a second nearly, while the coronal runs through, while this mass of ions runs through the Earth. You don't even know it. And then you turn it all back on. But just for a few seconds. It's quite interesting. Finally, there's the 11-year sunspot cycle. That's the middle picture in the top. And every 11 years, the sun's magnetic pole flips. North becomes south and south north. And when it does, it has a diminished amount of activity. And then the activity increases and increases. And after about 5 or 6 years, like right now, we get what they call solar maximum. We're in cycle number 25 right now, and solar maximum will be later on this year. And the way we count this or understand it is you look at the sun. I used to work at the National Hurricane Center, and my job was in the morning to go up on the roof, and they had a special scope set up, and look at the sun and count the number of sunspots and write them down, and then graph them. And the graph would look exactly like this red graph I have of solar cycles in the middle of this picture. And by the end of this year, we'll be at solar max, and then it decreases. And that happens regularly every 11 years. Also below that, there's a picture of a sextant, and I think I put it over on the table over here. Yeah. And a sextant is a tool that navigators use at sea or an airplane sometimes. And what you do is you look towards the horizon, you see the horizon, and then you pick a star, or in my case, you can pick the sun, and you measure the angle between the horizon and whatever astronomical point you're using. If you do that on the sun at noontime, when you're at sea, you get your latitude. So when I sail the boat across the Atlantic, that's what I use to determine my latitude. Longitude I determine at night by shooting stars. These are the sunspots I was talking about. This picture I took back in October when we had the partial eclipse. And you see those two little black spots on there. Those are sunspots. And if you look real closely, you'll see quite a few others. But the frequency and intensity of sunspots visible on the surface indicate the level of solar activity. And like I say, it goes through an 11-year cycle. It peaks and then it decreases to nearly zero. This picture, taken 2 days ago by a fellow who calls himself Craxus82, is cool because we used to not be able to take such good pictures of the sun directly. We had to wait for an eclipse to come by to see it all. Now, with technology And photography, digitized, we can do all kinds of fancy things. And this is a beautiful picture, in my opinion, of the sun. And you can see sunspots, flares taking place, leaping off the face of the sun. And I think it's remarkable that we can be able to do this. And this is an amateur photographer. There are a lot of people that are into astrophotography, and they take pictures of not only the sun, the moon, the planets, but also nebulas and things like that. And I'll show you a couple of pictures of them. Meanwhile, another fellow, Andy McCarthy, who's he lives in Arizona. He takes pictures from his backyard, as he says. Here's a flare to the south or downward from the sun that is 120,000 miles long. So you can imagine something like that extending out towards Earth and understand what a coronal mass ejection might have on Earth. We would feel it and see it. Fortunately, it rarely ever happens. The last time it happened was in, I think, 1860s or something. And it's called the Carrington event. And fortunately, we had no satellites, no electric grid. All we had was a telegraph. Well, it knocked out the telegraph system in the United States. It burned up several stations, it burned up the wires, and it knocked out communication across the United States at that time. And it's still referred to as a big event, the Carrington event. Meanwhile, astrophotography is a lot of fun. I've gotten into it living here in the village. First as a member of the Camera Club, I learned how to take pictures. Then I had the fortune of going up and spending a week with Tim Ernst and doing night photography, and got turned on to taking pictures of the Milky Way and then just scenery at night. There's a lot to do. The nice thing at night, particularly in the summer, it's nice and warm out. You hear the crickets, no one to bother you, there's no traffic, it's peaceful and quiet. And every year I usually take the Camera Club out and we take pictures of the Milky Way somewhere. It's a lot of fun. These are pictures that I've taken from the village here. On the upper left is the moon. Next to it is Jupiter and 4 of its moons. And these are all taken with my camera right here. And then next to that, there's a Milky Way with the playground over at Balboa Beach. I'm working on better ones of that. In between, there's a little black one there with a green dot in it, and that is a comet that came through the village about 3 years ago, and I took that picture from Balboa Beach. It's not fantastic. And then finally, in the lower left is a picture on Goose Pond Road of the Milky Way on an outing with the Camera Club. So those are just some samples of the kind of things you can take pictures of at night. And here are others. I've recently acquired a small telescope. It only costs like $500, which is relatively cheap. And it's really, really digitized and computerized. You use your cell phone for controlling it. And what I do is I place it out on my porch, and I can sit in bed at night, all night long, and I can tell it to go look for this or that star, or nebula, or galaxy, and it goes click, 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 it goes over and finds it, locks onto it, and I say take pictures, and it takes pictures. And the secret to taking pictures in astrophotography is to take a lot of pictures. And then you stack them up together, because each picture has a little bit of light, but if you add them all up, you start seeing a lot more detail. Like this picture on the far right, that is a nebula. That is Orion's nebula on the dagger of Orion. If you look up at the stars, you just see bright white. You don't see all the fancy little clouds and everything. But these are hydrogen clouds from an explosion of a supernova, and you can take pictures of them all around your heavens every night. So it's a lot of fun. And then the 2 pictures on the left, one are galaxies. The one in the middle is called the Cigar Galaxy. And the one on the left, I forget its name. Bode, B-O-D-E, Bode Galaxy. So I can sit in bed at night and I can take pictures of the stars. That's pretty cool. It's a lot of fun. And you get to learn a lot of things about our universe. Finally, Ready or Not is coming, April 8th. Be prepared, 25 days to go. And I wish you all a good sighting of the eclipse. And make it awesome, as I say. Plan to see it here. Watch it Monday, April 8th, 12:32 to 3:10. Watch it with solar glasses. Capture it on cell phone camera or memory. Grab a beverage and take a seat. This is a picture of me watching the eclipse, the partial eclipse we had back in October. There. Above 25 days to go. What I did is I took pictures with this camera, sitting in my backyard when we had the partial eclipse back in October. Then I took the individual pictures, or a series of them, 2 minutes apart, and I made them all about the same size, and I brought them into PowerPoint, which this is shown. I use PowerPoint because I know how to use it, and I put them all together along an arc, and I made this picture. So that's how I did it.
Yeah.
Does that answer your question?
Yeah, the key thing was I was trying to figure out whether I'm tracking and taking individual pictures, or whether I'm leaving the camera in a fixed position and then just letting the sun move through the shot and try to build it up that way.
No, I fooled you. I just actually took each individual
And then you
picture
just-
and put
you
them
just,
together.
You just post-process them into that.
Yeah.
Yeah.
Any other questions?
Where are you buying the film, the solar film?
Oh, there are many places. Any good camera shop will sell that stuff.
Where's a good camera shop?
B&H, well, I don't know if Bedford's in, the only camera shop that I know of around here is in Bedford's in Little Rock. I buy all my stuff through New York, B&H, but, and then there's an outfit in California, Thousand Oaks Optical, that sells very high quality solar filters, and there are many others. Just type online, solar filter.
Well, a 10-stop, neutral density.
It has, the f-stop, he's asking, when you get a solar filter for a camera, it should be of a certain, there's actually an ISO, international standard, that says it's supposed to be such and such value of f-stop and darkness that it creates. And you can look these up, but if it says NASA approved or ISO certified, then you know it's qualified material to use as a filter. And you can buy them in many places online. I'm sure there's lots.
You can even find them on Amazon. You just have to look up so you know the numbers you need, and you need to look up the size that your lens needs, and you can buy them on Amazon, and they range in price.
Thank you.
Sure. I just wanted to say we were at the Garland County Library yesterday and picked up some glasses. They have a big supply, and if you're pull the library card from there, they will give them to you. They gave me 4 of them, so.
So free glasses available at Garland Library if you are a card holder.
I think so. I have a question. When you're filming the diamond ring, do you have to have your glasses on, or is that close enough to need or not need?
That's kinda, yeah, that's pretty tricky. Yes and no. You don't want it to, when it's too bright, you can't look at it. Usually you're not looking at it, you just got the camera taking pictures. The secret is, as soon as it gets too, the light goes away, you have to take the filter off. Otherwise you'll see nothing. All right, well, I'd like to thank everyone for coming.
Peter, you might
Jay?
mention about not using the viewfinder. You use live view, not the viewfinder, not protected, even though you may have. to
Well, yeah, do not look through the viewfinder at the sun without a filter on, and even with a filter on, you should never use it because it doesn't always go through the lens. A lot of viewfinders are digital these days, and they bypass the lens itself. That's single lens reflexes used to have a mirror, and you would be looking through that mirror out through your lens. Today, they're mirrorless cameras, So they're just digital looking straight out of the camera without going through the lens. Very dangerous. Jennifer?
Yeah. Thank you, Peter. As Peter was talking about, some of the tips, we do have a sheet, if you didn't grab one at our, Camera Club table, this sheet will give you some tips on settings, and just different ways you can capture the eclipse. And, what I also wanna mention is, you see several cameras set up here, and you might see some of the things that we're going to use, some of our filters. Like Peter mentioned, there's lots of different filters you can use.